કેમ છો બધા? So we are meeting after a very long time. So first recall our last lecture. So last lecture was about grouping of capacitors. It means parallel combination and series combination. So in parallel combination, so you can see the first terminal of each capacitor is connected with the first terminal of battery, and second terminal of each capacitor is connected with the second terminal of battery. It means all are connected parallel. Equivalent capacitance C equivalent is equal to sum of independent capacitance. So that is C1 plus C2 plus C3. And total charge is Q, then charge on each capacitor, that is Q1, Q2 and Q3. So that is equal to Q1 plus Q2 plus Q3. So C equivalent C1 plus C2 plus C3. So if there are two capacitors, then you can say C equivalent is equal to C1 plus C2 plus, and charge Q1, if you know the capacitance C1, C2 and C3, if C1 and C2, then charge Q1 is equal to C1 upon C1 plus C2 into Q, and Q2 is equal to C2 upon C1 plus C2 into Q. If n capacitors are connected parallelly, then C equivalent is equal to n into C, and charge on each capacitor Q dash is equal to Q by n. So all these are the shortcuts. Now for series combination, in series combination, first terminal of each capacitor is connected with the first terminal of battery, second terminal of first capacitor is connected with first terminal of second capacitor, and so on, and last second terminal of last capacitor is connected with the second terminal of battery. Then we can say all are connected in series. So in series combination, charge is same on all capacitors. So you can say Q is same. Now total potential V is equal to V1 plus V2 plus V3, and equivalent capacitance C equivalent is equal to 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So if there are two capacitors, then we can say C1 C2 upon C1 plus C2. It means multiplication upon addition. So remember this, we will use this in the examples. And potential V1 across the first capacitor, that is equal to C2 upon C1 plus C2 into V. So shortcut is, if it is 1, then here use 2. If 2, then again 1. So C1 upon C1 plus C2 into V. So another option is, if you know Q, if you know C1, you can find out V1 very easily. Q is equal to C1 into V1. So V1 is equal to Q upon C1. Or you can use this equation. If n capacitors are connected in series, then charge Q dash is equal to Q, and potential V1, so V dash is equal to V by N, and C dash is equal to C by N. So C equivalent is equal to C by N, V dash is equal to V by N. So you can see this curve. So this is parallel or series, so parallel combination. Then redistribution of charge between two capacitors. So redistribution of charge, it means first two capacitors are charged independently. Okay, after disconnecting from the battery, they are connected parallel. It means positive terminal is connected with positive terminal, negative terminal is connected with negative terminal. So initial potential difference may be different, but after connecting, okay, so charge will be redistribution to equalize the potential. So final charge, so you can say these two capacitors are in parallel, so you can use equations of parallel. So Q1 dash is equal to directly now you can say C1 upon C1 plus C2 into Q, and Q2 dash is equal to Q C2 upon C1 plus C2. Common potential C1 V1 plus C2 V2 upon C1 plus C2. So we have derived all this relation, okay, initially. So delta U C1 C2 upon twice C1 plus C2 V1 minus V2 whole square. If they are connected oppositely, it means negative terminal is connected with positive terminal, then consider difference of charge. So you can say V is equal to Q1 minus Q2 upon C1 plus C2. So C1 V1 minus C2 V2 upon C1 plus C2. Then we have discussed in series combination, final capacitance is less, while in case of parallel capacitance is higher. If n plates are connected, okay, then all are connected in series. So C upon n minus 1, here it is n minus 1 into C. So all these plates, so even number of plates and odd number of plates all are connected. So you can say n minus 1 capacitor, so n minus 1 into C. So next most important topic, and that is network solving. So generally in practice we use mixed combination of capacitor. It means may be connected in series, may be connected in parallel, or combination of all. So there are various types of circuit. After combining all the capacitors as per the need, generally we have to calculate the what should be the charge of battery and what should be the potential of battery. So for that we need equivalent capacitance and charge on each capacitor, as well as total charge required to charge all capacitors. So for that we will solve circuits step by step. So these are the steps that we have to follow. So now consider, suppose so consider suppose okay, now suppose there are four capacitors, and at present suppose we cannot say all are connected in series or in parallel. So if suppose all are connected in such a way in mixed combination, then we have to follow the guideline. So as per the guideline, suppose first step, then first step, so identify the 2 point across which the equivalent capacitance is to be calculated. So suppose here there may be 4 points. So out of 4 point, suppose find out 2 point across which we have to calculate capacitance, or you can say equivalent capacitance. Then draw a battery between these two. So in the next example we will consider all such things. Okay. then and start to solve the circuit by considering the farthest point. So first consider farthest network point and then calculate all capacitor. So now consider suppose first circuit. Now you can see there are 3 capacitors, 3 microfarad, 6 microfarad, 3 microfarad connected between point A and B. So our aim is calculate equivalent capacitance between point A, B. So now these 3 are connected in series or in parallel. So the mix combination. Okay, so start with simplest way or from the farthest point. So farthest point is this. So now first consider these 2 capacitors. So these 2 capacitors are connected in series or in parallel. So both are in series. So find out first equivalent capacitance for these 2 capacitors. So for series combination already we have derived the relation C1 C2 upon C1 plus C2. So you can see these 2 are in series combination. So 3 into 6 upon 3 plus 6. So 3 into 6 upon 3 plus 6. So 2 microfarad. So now instead of 2 capacitor, now you can consider single capacitor. So now this 2 microfarad capacitor is connected in parallel with 3 microfarad capacitor. So you can see these 2 and 3 both are parallel. So now again for parallel combination, instead of these 2 we can use single capacitor. So for parallel combination C1 plus C2, it means 2 plus 3, so that is equal to 5. So you can replace this 2 capacitor by single capacitor with capacity of 5 microfarad. Now consider this next circuit. Again you can see 6, 6. It means total there are 5 capacitors. All are with different capacitance. Our aim is we want to find out the